This experiment is to demonstrate you Newton's third law of motion. You know Newton's third law. Each action has equal and opposite reaction. If two bodies A and B exert force on each other, the forces are equal in magnitude, opposite in direction. To show this, I have balance. When someone pushes the pen down, the needle here moves on this dial, which is calibrated in grams, so that I know what force the pen has been pushed. As you push the pen harder, the needle will move through a larger reading, and so I can quantitatively measure the force. Now I also have two magnets. These are the two objects A and B. These two magnets will exert force on each other, attraction or repulsion depending on how I place them, and that force we will measure with this balance. On each of these magnets separately we will measure the force, and we will see that they are equal and opposite. This is a stand. I have made this a stand using a PVC pipe. This is a PVC pipe, and this is joined to this plastic piece through M-seal. That black thing is M-seal used by plumbers. So with the M-seal I have joined this plastic sheet and PVC pipe to make a stand. Stand is such that my magnet can go in this pipe. So this magnet I can put in this pipe and can just go and stay at the bottom on that plastic sheet. So these are our apparatus, and with this I will demonstrate you that force between these two magnets obeys Newton's third law of motion. So let's start measurements. Keep your eyes on this dial, because that will measure how much force is being exerted on the pen. When something presses the pen, then the needle moves. You see the reading, and with that reading you know how much force is exerted on the pen. So first I put this stand alone, no magnet in, and see the needle reading. It is 50 grams. So the stand is pushing the pen with a force of 50 grams weight. And now I am putting one magnet into this stand. Still 50 grams. Needle is reading 50 grams, and now I have left it here. So the magnet has gone in the stand, and needle has advanced to 90 grams. So the magnet alone is 40 grams. Magnet itself is pushing it by 40 grams. The stand is pushing it by 50 grams. The total push downward is 90 grams. That is being read here. Okay, this downward force by the stand and magnet on the pan is 90 grams weight. So the reading is 90 grams. Now the other magnet. This is second magnet. Say magnet B. This magnet also I have to put separately. First let's see what is its mass. 40 grams, right? It's reading 40 grams now. The other magnet here. Two magnets are identical, so it is each of them is 40 grams. Now the second magnet I am putting in the PVC pipe, and in a way so that similar poles will face each other. The two magnets will repel each other. One magnet is already there in the stand, and the second magnet I am going to put in repulsive mode. And you see, if I put it here and bring it down and leave it, what happens? See, the upper magnet is floating in air. It is not falling down. It is not going up. It stays in equilibrium at a particular height because the lower magnet is pushing it up. The upward force by the lower magnet is balancing its downward weight. Earth is attracting it down. You have seen its mass is 40 grams. So Earth is attracting it down by 40 grams weight. The lower magnet is repelling it, applying upward force of 40 grams weight so that it stays here in equilibrium. So one force I have measured, force on the upper magnet by the lower magnet is 40 grams weight in upward direction. So remember this, force on the upper magnet by the lower magnet is 40 grams weight in the upward direction. Now I have removed that second magnet. One magnet is still in this stand. I am putting it here. It is 90 grams as it was earlier. 90 grams. The stand is 50 grams. One magnet is 40 grams. So this total reading here is 90 grams. Now I'll put the second magnet in the same way as I showed you earlier in the repulsive mode, so that the upper magnet is floating in air, and you see the reading, it has gone up from 90 grams, it has become 130 grams, and reading increases when someone pushes the pan down. So which object has exerted this downward force? From 90 it has become 130. So something is pushing the contents on the pan downward. And this downward force, how much it is? 130 minus 90, that is 40 grams weight. And it is the upper magnet. It is the upper magnet which is pushing the lower magnet down. That is the repulsion. You know, similar faces I have put facing each other, similar poles. So repulsion, so upper magnet is exerting a downward force on the lower magnet, and that downward force is being measured here, is being shown here on this dial. It has gone from 90 to 130, so that downward force is 40 grams weight. So what did we see? We had seen earlier that this lower magnet exerts force on upper in the upward direction. That we had seen earlier. This is because of the equilibrium of this upper magnet. Now with this balance we have seen that the upper magnet exerts force on the lower magnet in the downward direction. From 90 it has gone to 130. And the two forces are equal, 40 grams weight on the upper magnet, 40 grams weight on the lower magnet, and the two forces are in opposite directions also. Lower exerts on the upper in upward direction, and this upper magnet exerts on the lower in the downward direction. So the two forces are equal and opposite in direction and act on two different bodies. That is third law.